we're graphing exponentials. Exponential means x is up in the power zone. What do you do when x is up there in the power zone? I'm going to just make a table. I'm just going to make it a little XY table and just plug in a couple numbers and just play connect the dots. Just get a couple dots on the graph and graph it out. So what's the easiest numbers in the world?
1 and 5.
0. Is that the easiest number you know in all the world? 0 and 1. Right? 0 and 1, two easiest numbers in all the world. So let me put in 0 and 1. And let's just plug those in to that equation. So this is going to be y equals 5 to the 0. So what is 5 to the 0?
0.
Uh-oh. We need is just 5. Okay. So which of those graphs now, so an exponential graph, which of the graphs has the points over 0 up 1? B does. That's over 0 up 1. Well, so does C. D does not. Which one has the point over 1 up 5? B's looking good. Over 1 up 5. Well, so's C. C also has over 1 up 5. A and D are out at this point. Well, I guess it kind of does. Okay, but you know what? There's no way it's A. A is a line. Linear. Do you know what I mean by linear? A is a straight line. This is an exponential equation, which means it's going to curve up. It's not going to go down to this side. So let me just give you the basic look of an exponential. They go up on one side and they flatten out on the other. So exponential means x in power, and what they'll do, the graphs always rocket up on one side, flatten out on the other. This making sense? So an exponential graph always rockets up on one side, flattens out on the other. So really we knew it was going to be B. Well, yeah. I'm trying to give you part of the information. There's a whole sea of information. We don't have time for the whole sea. It can be flipped. They can take those graphs and flip them and turn them. So when I say it rockets on one side and flattens on the other, know that it can do that in different directions. How about that? It can do that right or down, right and up, right and down. It can do that in different directions. So these 2 points and that general information tell me the answer is B on that. Basically, I'm trying to save you time. If you want to plug in more points, you'll find that B is the right answer. But I think those 2 points are good enough for now. C also has those 2 points. I guess A does too. They're being pretty tricky. Yeah, maybe I should do one other point. If you plugged in -1, yeah, that would decide the issue. If you put in -1, watch what you would get. 5 to the -1 power. Now, what's 5 to the -1 power? Yeah, negative powers are unhappy. They're unhappy where they're at. They flip 1/5. So -1, 1/5. So where is that? Back 1, up 1/5. I don't know if you can see, but B has that point right there.
The beginning of the curve out.
Yeah, back 1, up 1/5. Whereas no way C has that. So, all right, enough said. I'm going to move on. So just plug in enough points until you can tell which one has those dots. And start with 0 and 1 for x. Try the same thing on that one. Try number 2. Make a little XY table. Put in 0 and 1. This making sense? So make a little XY table. Put in 0 and 1. What is a half to the 0 power?
1.
Yeah, anything 0 power is 1. What is a half to the 1 power?
Half.
It's going to be a half, huh? So let's do the graph. Now, this is exponential. So which one's going to have the point over 0 up? Well, it's going to be like this, over 0 up 1. and over 1 up a half. So it's kind of coming down, huh? It's coming down to the right, you notice? So which one of those graphs looks like it's coming down to the right? Well, kind of A does and D does at first, right? We good so far? Both of those are coming down to the right. Everybody tracking with me so far? See this little piece? It looks like it's kind of going like that, right? Just by connecting those two dots, looks like it's going down to the right. Am I going too fast? That's good. Now, how do we know whether it's A or D? Well, it's not A, huh? Because look at A. Right there at 1, it's at 0, actually, isn't it? It's already at 0, but at 1, it's supposed to be up above 0 at a half. So the answer is D.
Does it only flatten on one axis?
Yeah. What's hard about this is there's a whole deep story. Take pre-calculus, we go into the whole story. So we just don't have time for that right now. So to answer your question, it's a good one. It can flatten on different axes. It doesn't have to be it can flatten on different lines. It doesn't have to be the axis. So in other words, sometimes the graph will flatten down to below the axis like that, or do other things. It can do different things. It's going to flatten somewhere. Yeah. But it can flatten different places. Yeah, so basically, know this. An exponential graph always rockets on one side, flattens on the other. And then just get a couple dots. Is that good? So at this point, we're just expecting exposure. We just want you to generally see a couple exponential graphs. Want to try number 3? See if you can do the same thing. Notice there's no parentheses around that -3, right? So that negative is not involved in any power stuff. It's outside of that, huh? Okay, let's try this one. So if I may, I'll just come down here, make an XY, or maybe over here, make an XY table. So again, 0 and 1, y equals -3 to the 0. So that's going to be, what is that? -1, good. And then what about -3 to the 1? That's just -3. So that wasn't too bad. So over 0 down 1, and over 1 down 2, 3. So that graph's going down to the right, isn't it? So which graph is it? Yeah, it's got to be B, huh? It's going down to the right. How are we doing? This making sense? Feel like this okay? So all you got to do is get a couple of points. Usually 2 dots is good enough. They just want general exposure. Just have you generally seen what happens when X is up there in the power zone? So that's what's special about these. These are called exponential because X has climbed into the exponent zone. X is up there in the power zone. Okay. What should we do there? We're trying to solve for X on that one. How should we do it? So, can you tell what X is? 4 to what power 16? Yeah, can you just see it's just 2? Can you just solve by observation, that's called, just by looking at it? 4 to what power 16? It's got to be 2, huh? Now, they're going to get a little more tricky. Let's try number 17. 16 to the 3x minus 1. Number 7, I mean. 16 to the 3x minus 1 is 4. All right, how about that one? I'd be impressed if you could just look at that one and see the answer. All right, I'm assuming you can't. That one's too hard. So do you understand what's kind of weird about that question? X is in power, huh?
That's 2 again.
I don't think so. What are we going to do to solve for that? Could I divide by 16? I'm trying to get X alone, right? You know what I mean? Think with me. I think I'm about to show you what to do, but it'll stick in your mind way better if you just think with me for a second about what you would try to do. Yeah, try something. Why don't you try something on your own papers there?
Log 1 and 3.
Or rather than guessing, let's give up on the guessing. Guessing is too hard on this one. But just try to do something to get x alone. You know what I mean? Like x is over here, x is saying, I want to be alone, right? That's what we do when we solve for x, right? X is saying, I want to be alone. Get rid of this 16, please. Get rid of this 3. Get rid of this -1 so that I can be alone. Well, how are you going to do the very first step? How are you going to get rid of that 16? Do you see how different this question is from what we normally do? If that was 16 times 3x minus 1, then I could get rid of the 16 just by dividing. No problem. Gonzo, right? And I'd be on my way. I could do it. But that's not going to work when it's 16 to the power 3x minus 1. That's different than just 16 times 3x minus 1.
Do you divide with the power on both
Maybe
sides?
multiply everything.
Do what's that? Divide by the 3x minus 1?
Yeah, on both sides.
So like just divide. Well, and hope that'll cancel it out? That's not the opposite though, right? Right? Whenever we do a math operation, we do the opposite. And that's not, if that was 16 times 3x minus 1, then you could divide and it would cancel because dividing is the opposite of multiplying. But it's not 16 times 3x minus 1, it's 16 to the 3x minus 1. See the difference? Yeah, rooting is the opposite. But what are we going to root? It's a weird root, huh? It's a weird power. All right, so have we sufficiently seen that it's something new? I think that's a lot of the battle in math, is really helping you to see it's something new so that when you see it on the exam, it'll key your memory. So you see how hard it is to get that x alone. It's not multiplied. X has climbed into power. That's the problem, right? How do we get rid of that x out of power? What we do, in this case anyway, is we make both bases the same. If we can make both bases the same, then we'll be able to do something. Let me show you. So I'm going to make both. So when x is in power, which it is right here, make both bases the same. So step 1, make both bases the same. Then step 2, drop the bases. Powers are equal and solve. All right, so what do I mean make both bases the same? What are the bases? What do we mean by base? What are these things called down here? The what boards? The base board. So what does base mean? Just thing on the bottom, huh? Just the bottom. So the 16 and the 4 are the bases. How can I make them the same? 16, isn't that 4 squared? And just everything else is still there. I just made the two bases the same. Without changing the problem at all. That's still a 16 over here, isn't it? That's still 16. 4 squared is still 16. But now it is written as the same base as the other side. Do you see what I mean by that? I made the bases the same without changing anything that's really there. I just made it look different without being different. Okay, good. Did a little plastic surgery. I removed the wrinkles. It looks different. It's the same person, though. Right? Same exact. That's still a 16. Now, why is that so great? Well, once the bases are the same, so make the bases the same, then you can drop the bases and just set the powers equal. What's the power? This has power 2 parenthesis 3x minus 1. What's the power on the other side? What's the power over here?
1.
Yeah, if there's nothing there, that means there's an invisible 1, right? Because 4 to the 1 is just the same as 4. So set the power. See how the power came down? The power came down. You drop the base. Now, why? Why are we allowed? I don't want to just tell you some math rules. They won't stick with you very well unless you feel their truth. Do you see why that's got to be the case? Think with me logically for a minute. If I told you, hey, guys and gals, I'm thinking of something 4 to the third power is equal to 4 to the what? Well, it's got to be third power. If that's got to be a third power if the bases are the same, right? They're both 4. And one of them's raised to third power. The other one has to be third power or they wouldn't be equal. If this was something different like a 2, well, then they wouldn't be equal. You agree with me? Once you've made the bases the same, the powers have to be equal, don't they? Or the things would not be overall equal. So you see, once I've made these bases the same, right? If the bases were different, that would not be the case. Am I saying too much information? If I said 2 to the third is, I don't know, 8 to the what, I have no idea. I don't know. It's not going to be the same. But if the bases are the same, the powers would have to be the same, or the things would not be overall equal, right? If the powers were different, 4 to one of them wouldn't equal 4 to the other. All right, so once you've made the bases the same, you can cut them out. The powers have to be equal, and now we can solve. See how that helped us? We can solve this. Once we get that stuff out of power, do you see how that's the problem? We have to get that stuff out of power. How do you finish solving for x there? Just add the 2. Yeah, we're just doing normal steps now. So 6x is 3. Last step. Divided by 6. What's that? 3/6? 1/2. That's our answer. All right, so do you see the game plan? This is what you want to be clear on. Try that one. So you see how x is in power? So that's how you're going to recognize these on the test in a week. When x is in power, you right away say, oh, what do I got to do? I got to make the bases the same. Now, those are big numbers. What I would suggest is change both bases to be 5. You can make both those numbers out of a different base. Make them both out of 5. What do I mean? 25 is 5 to what power? 5 times 5, 5 squared, huh? So make that 5 to the 2, and then the x is still there in the power where he was all along. See how that left side is still 25 with an x in the power zone. It's just being written as 5 squared. It's still a 25 though, isn't it? Now how about the right side? If you're not familiar, just take your calculator and take 5 times 5 times 5 until you get 125. Hey, you know 5 quarters is $1.25, right? So it's 5 times 5 times 5. So that side is 5 to the third power?
So it wouldn't work if we did 25.
It would, but that right side is not 25 times 25. Try it on your calculator. Good question, Evelyn. Yeah, that right side, the reason we couldn't do the 25, it's a good question, is because 25 times 25 is 625. It's not 125. It goes right on past it. Good question. That's why I didn't make them both 25. Does that make sense? The right side, so take your calculator and take 25 times 25, and you'll see that that's 625. The number on the right cannot be made out of 25s. There's no way to do it. It's not 25 to a whole number power anyway.
So would we want to go for like the lowest number that goes?
Yeah, you just got to find a number that can make them both. Just any base that they can both come from. So they both come from 5. They don't both come from 25. Now what do we do? If 5 to something is equaling 5 to something,
You drop the power.
yeah, those somethings have to be equal, don't they? If they were different, then 5 to one of them wouldn't equal 5 to the other, right? That's logical. So drop the bases. 2x has to equal 3. Last step. Divide by the 2. 3/2. It's making some good sense. We'll go grab number 9 here. 6561. 6561. That's a big ugly number. I don't expect you to know that off the top of your head. Use your calculator. To the x minus 3, 27 to the 4x. Okay. Any guesses what we might make both those out? Look at that 27. He's easier. Look at 27. What does 27 come from? Bunch of 3s, huh? So take your calculator for the 27. Start going 3 times 3 times 3, or maybe you already know off the top of your head how many 3s. And then you should think, hey, I bet that's 6561. I bet he's a bunch of 3s too. Take your calculator and go 3 times 3 times 3 times 3 till you get there. Or just use your power button if you want. If you know how to use that, it might be quicker. Either way, find out how many 3s to make 6561 and how many 3s to make 27. Make them both out of a base of 3. So make the bases the same, and then drop them. Set the powers equal. So isn't this like, what is it, 3 to the 8th? Is that what it is? 3 to the 8th. Now, the x minus 3 is still there. The parentheses is a good idea. This is 3 to the 3rd, and the 4x is still there. See what I did there? So I just from my calculator, well, actually, I got it from you all, but you would get it from your calculator. 3 to the 8th power is 6561. 3 to the 3rd is 27. Now that we've made the bases the same, we can chop them, right? So chop those bases, keep going, I'll let you finish that one. All right, so now we can cut out the bases. Because if 3 to something is equaling 3 to something, those somethings, those powers, have to be equal, don't they? So 8 to the x minus 3 is 3 times 4x. And what do we get? Boom, boom. 8x minus 24 is 12x. We good? You all are pros at solving these kind of things now. You laugh at equations like this now, right? Got to get rid of the x's, one of the x's, right? What's that? 4x, last step. Divide by 4. X is minus 6. How are we doing? We okay with this? I'm not getting a lot of reaction. Do you want to do more of these? How you doing? Is this okay? How many got that one? Let me see, show of hands. How about that? Okay, looks like majority of you are on track. Anything I can help with on that one?
I got 6. Why did I get that?
I flipped it.
What do you mean flipped it?
So instead of moving the 8, instead of minusing the 8x, I just brought the 12 over the other side.
Okay, yeah. Let me jump up and do that with you, Erica. 8x minus 24. So you mean you had it like this, and then you subtracted 12x from both sides, or you just jumped it over?
Yeah, just jumped it over and there was a 24.
Okay, that's great. So 8x. Now what happens when that 12x jumps over to be minus 12x? The minus 24 jumps over to be plus 24, right?
Right.
Do you remember to change all those signs? And then what's this? It's not 4x, it's minus 4x. 8x minus 12, right? You're subtracting 12.
Yep, I just didn't carry that over. Thank you.
Last step, divide by minus 4. There we go. Good. Yeah, it'll work either way. You can totally go either way. We good on that? Anything else I can answer? Good. Please ask that stuff. Let's try it. This one's tricky. Are you feeling tricky? What do you do with that 1 over 25? Remember what we learned? What makes something flip like that? Negative powers. So just think, okay, how do you get 25? 5 squared. But how's it going to flip? Instead of 5 to the positive 2, it's going to be 5 to the negative 2, right? That's what makes that 1 over 25. It's 5 to the negative 2 power. Remember, negative powers are unhappy, like somebody who's unhappy at their job. They want to jump to a new job. So this is 5 to the minus 2, and the x is still there. We good so far? So negative powers, remember, they make things jump to the bottom. They're unhappy at their job. They want to jump. Unhappy at their spot in the fraction. They want to jump to the other side. So other side is 5 to the 3rd power, right? Just use your calculator. 5 times 5 times 5. Like that. We good? All is good so far? And then this power's got to equal that power, right? Because if 5 to something is equaling 5 to something, the powers have to be equal. Because if they were different, then 5 to one of them wouldn't equal 5 to the other. So minus 2x has to equal 3 times 4 minus x. Distribute. 12 minus 6. What do you do when you have x's on opposite sides? Get rid of one of them. It doesn't really matter which one. I'll add 3x to both. So that's just 1x. Oh, that's nice. Just x is 12, huh? Is that okay? So the main test is they're making you remember fractions mean negative powers. A negative power flips it. It doesn't put the negative in the front, does it? Negative powers flip. They don't put a negative in the front. So that's real important to remember on that. We good? We're almost done with this section. Only 2 more, and then we can go on to the next section. So, blah, 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 blah. Formula. That's all I need. Y equals 40, point, what is it, 0.975 to the 8. You don't need that 0 in front of the point, doesn't matter. And then right there they say let x be 60. So just pop a 60 in and hit the buttons on your calculator.
Oh, that X will be 60.
See, it says right there, let x be 60. So just grab that 60. This is going to be easier. We don't need to solve it. Just put a 60 in right there. So that's going to be 40. They just want to make sure you know how to do this on your calculator. So can you type that into your calculator? I'll do mine as well. Got to use the power button, which is, so you're going to go 40 times, you don't need parentheses, 0.975 to the power. Now your power button is either X to the Y, or it might be an up arrow, kind of depends on your calculator. So that's the button for the power. X to the Y or the up arrow, 60, and then hit equals. I'm getting 8.75, whatever. I don't know how many places. 100th place. They want 2 places. 756. They want me to round it. 76. 8.76. Is that coming out okay for you? Can I help with that? They are giving you a little bit of information. They're saying, where is it? Oh, Y, all you need for is the number of students studying. Oh, no, you don't need, we don't care about that. X, so who cares about the Y? But here's what we need. X is the number of years after 2007. See how they're doing that there? X is years after 2007. So then in part A, when they ask you about the year 2012, yeah, that's 5 years after 2007, huh? 5 years after. So that means plug in X equals 5, because X is the years after 2007. So if it's 2012, that's 5 years after. So plug in, so just take their formula, wherever it is, there it is, and plug in X is 5, is all they want you to do. Just grab the 5, put it in right there. So part A will be 259.282 1.07 to the 5. Let's see what we get. 259. I'm kidding. I got 363,656. They said round to the nearest whole number. So 363,656. Coming out okay? And then part B, the year 2021. So in the year 2021, what's X? I don't know. 2021. How many years is that? Subtract 2007. Yeah, that's 14 years after X. So X has got to be 14. So now we're going to plug in 14. 259.282 1.07 to the 14. I'm just going to hit the buttons and you can get it, right?